Okay, thank you, welcome all. You know, the title of this talk reads like a PhD thesis. You know, ZettaFlop scale Uber CPU GPU network for AI and spatial computing. How many deep tech computer people in the audience? No one. Good. So, you know, my role as chief scientist for this new initiative, which is the first time we are talking about here. So the group of you here are the first to hear this. So when I heard the word chief scientist, or some people hear the word chief scientist, you may have a picture like this, right? Like, you know, it's some magician that creates, you know, some new thing, an alchemist sort of thing. Now, that's really not the kind of you know, science that I do. I deal with numbers. I deal with computation. I deal with transistors, designing GPUs all my life, 25 plus years. Designed many GPUs on which, you know, the first crypto mining happened way back in 2012, 2013 timeframe. When you know, so what I wanted to talk about is something very fundamental. Okay, it won't be a PhD thesis, I promise you. Okay, the fundamental thing about the GPUs and fundamental thing about AI and blockchain and everything is the hint is in the welcome here. So does anyone know what this number represents? Welcome to token 45001000. So that number is 2049 in the floating point format. Okay? So the core to computation in a computer, in a GPU, is this number called floating point format, right? And see, 2049, you and I can read it, understand it. The computer notation, we created this notation called floating point notation and store it in this format. Why did we create floating point format? Because the integer format, we couldn't represent, right, you know, the scale of things that we needed to simulate from a size of an atom, right? Like, you know, a small thing, 0.0001, 10 to the power of, you know, -9 meters, to like this huge, you know, 4936 to the power, 10 to the power of 13. We couldn't represent with integers. So we needed to come up with a new format, and that's what the floating point format is. So that from the size of an atom to the size of the whole solar system, we can represent with these numbers, right? And that's the magic, right? With this magic, what did we do? You know, this floating point enabled us to simulate the entire world, right? From submicron scale to cosmic scale, okay? And this is why our lives depend on computing right now, right? So what did we do with this? We have our entertainment in the form of games, movies, you know, coming through this floating point operations. Education, you know, if you look at ChatGPT as an education mechanism, right? It is because of this floating point operations. Exploration, you know, you can do simulated space travel. You can simulate a robot on a computer. And then, of course, the central to this conference, economics, right? You all used computation to do validation of you know, various transactions. So whether it's games, digital twins, neural nets, and crypto, they all depended on this fundamental thing called a floating point operation. Okay, that is what we call a flop, right? A floating point operation. So I'll give you a scale of this operations kind of that you see, right? So they're called teraflops. That is 10 to the power of 12, one and like 12 zeros, floating point operations. You find this literally in a billion GPUs, gaming GPUs from Apple, AMD, Intel, NVIDIA, okay? This teraflop scale. You know, when the first teraflop GPU shipped, it was 2008, okay, 2008. So that's roughly 16 years ago. Every year, there are over 50 to 80 million of these GPUs that ship, new GPUs. So up to this point, if you just look at the install base of a teraflop GPU, you have over billion of these GPUs out there. Now, it's really interesting if you multiply billion by a trillion, which is teraflop, you get 10 to the power of 21. That's a zettaflop, okay? That's a huge number. So if we can collectively leverage all these flops that are sitting with the gamers, that are sitting in your MacBook, that are sitting in your iPhone, that you're sitting in your iPad, right, or an Android tablet, you have a zettascale network, right? And this number is a huge, huge network. And I'll tell you why. And similarly, another important one is a petaflop, okay, which is 10 power 15. This is the scale of compute you see in AI GPUs like NVIDIA H100, B100 or B200 that they just launched. These are petaflop GPUs. You mainly find them in servers. And mainly, most of these GPUs are sitting in big data centers, that owned by Microsoft, OpenAI, Facebook, and all. There are a few. Maybe some of you have some of these GPUs as well, right, that you could utilize. And again, interestingly, a million petaflop GPUs is also a zettaflop, right? So, a million of these clustered together can create a zettaflop network. Now, OpenAI, the leader in AI, said that the amount of compute required for these large AI models is, it's doubling every 3 to 4 months, okay? So, 5 years ago, nobody thought we would be needing zettascale compute. When I said by 2025, everyone needs a zettascale compute, people laughed at me. I said it in 2020. So what's happening? The super rich are building these zettascale data centers. It costs one zettascale data center costs you over $70 billion, okay, and over a gigawatt of power. Okay, $70 billion. Now, if you look at NVIDIA revenues every quarter, they are shipping zettascale compute every 2 quarters. Every 6 months, they're shipping like $70 billion worth of compute. And several big companies, like I said, have this scale today and building more. Now, my dream, and I've said this 6 years ago, that I wanted to have petaflops of compute, petabytes of storage, less than 10 milliseconds away from every person in the planet, right? And this dream can only be enabled with a decentral network, okay? And with incentives for everyone who contributes this compute, whether it's your gaming GPU, whether it's your data center GPU, if you contribute this to the whole network, that's when we can enable this zettascale compute for everyone. So I'll show you kind of illustration, because there are many gaming GPUs that cost only $300, $400, that are 10 to the power of 14, right? That are 100 teraflops. And you have some expensive GPUs at 10 power 15 you can buy at $10,000 or so. So if there is a network of all of this across the world, and they are connected with one protocol, you get your zettascale network. And that was the our foundational architecture behind what we call the new network that we are developing, called the Axlflops network. And again, ladies and gentlemen, I'm really proud to introduce this new network that we have been working on called Axlflops. And this is the network to deliver zettascale at a global scale, right, for everyone, okay? And what are some key attributes of this network, right? It is heterogeneous, real-time GPU scheduling. What do I mean by that? That means that you can use GPUs from all vendors, not just NVIDIA. You can use an AMD GPU. You can use an Intel GPU. You can also use other people's AI hardware, okay, on this network. And more importantly, our network is not just limited to AI. You can do games. You can play games on it. You can do pixels that GPUs are very, very good at. You can do simulation. You can do digital twins and all. So we have this low latency network that we created. And we have, in terms of the tokenomics and all, which I'm not the expert in, but we have a white paper coming. It's a dual token architecture. We have white paper coming very, very shortly on this network, detailing all of this stuff. But we aren't stopping there, because we want to get, this is a 10-year initiative for us, right, to get this network going. We are also announcing a deep tech fund called Axlflops, with the goal that we want to get ZettaFlop level computing, the new GPUs, to less than $1 billion cost. So new transistor technology, new packaging technology, new memory technology. So our fund will be investing into many of this new container technology. And as I heard many talks today, security is a big issue, right? We haven't really completely solved privacy and security issues. So investing into those areas as well is very, very important for us. And so again, we are taking a comprehensive view, going to the foundation of this computation, which is the flop, right? An accelerated flop is what created this whole thing, right? People use buzzwords like AI or this or that. They come and go. But what stayed with us is the mathematics, right? Math is the new fire, right? New electricity. And that is what is, powering our future, our past, our current, and our future. And we are building a network based on mathematics, which is the floating point operations per second. And we're super excited, and we are also taking an approach where we're bringing everybody along and also investing into the future and into the future of math with this deep tech fund. So thank you for giving me this opportunity to present Axlflops.